typical task of a data scientist is the application of models to data, and at some point you'll encounter a dataset that contains outliers. Outliers are data points or observations that fall outside of an expected distribution or pattern. For example, if we were to approximate our data with a Poisson distribution, then the outliers are the observations that do not appear to follow the pattern of a Poisson distribution. The same concept follows if linear regression were the model of choice, and a residual plot indicated that a small minority of observations appeared to be different from the majority. For some applications of linear models, the presence of aberrant residuals may violate many underlying model assumptions, such as the assumptions that the observations were taken from a population with a normal distribution. The discovery of outliers generally occurs during the EDA stage, and the decision for how to deal with them can have repercussions for the entire workflow, even potentially limiting a project's impact on the business. The first thing to keep in mind when dealing with outliers is to ensure that they are identified and tracked in a systematic way. This generally involves data visualization where the color scheme on scatter plots and histograms is configured to provide guidance and insight. As we've seen in the previous unit, we're not limited to 1- and 2-dimensional spaces, because techniques like PCA and TSNE can project high-dimensional data into these more familiar spaces. These visualizations can lead to the important discovery of what constitutes an outlier in a particular dataset. An observation apparently different from the rest may exist as a true outlier because of instrument errors, like a need for calibration, or human errors, such as the mislabeling of samples. There are numerous other reasons, but it's important to note that an apparent outlier may in fact be as valid as the rest of the data. It's important to learn as much as possible about data points that appear to be outliers, and this will likely involve a discussion with domain experts. In some cases, like customer churn analysis, the positive class may exist as an extreme minority, and when class imbalance is severe enough, then even techniques like SMOT and oversampling may not suffice. Fortunately, there are outlier detection and novelty detection algorithms that fit this exact type of situation. Outlier detection is used for systematically identifying observations that are different from the other observations in data we've already collected. Novelty detection is focused on detecting outliers during the process of collecting new data. The application of the algorithms discussed in this unit can be used in classification, regression, anomaly detection, quality control, and the creation of new features for subsequent machine learning.